So, welcome everyone. How's the conference been? Good?
Great.
You guys enjoyed all the new stuff we are doing for you? Okay. So, thanks for coming to the talk. It's noon, almost ready to go home, so appreciate it. I'm Sridhar Madhugiri. I'm a developer on the C++ team. I've been on the team for about 15 years. I've worked in different areas, but mostly on the library side. And most recently, I've worked on CX, which is our extensions for targeting WinRT store application APIs. So today, I want to focus on some of the patterns that cause performance issues and how you can get around those, go into some of the common issues we have seen, and we'll go into those details. So let's talk about motivation. We did a lot of investigations over the last year. Once we shipped Windows 8, people picked up Visual Studio 2012. They started writing applications. We looked at internal applications that were written in Microsoft, either that ship outside or somebody just was trying out some project. We looked at samples that were written by different people. We looked at feedback from customers. And that was one of the inputs into this talk. What we found during that was there are some patterns that result in unanticipated perf issues. It's not very obvious. You look at the code and you say, OK, it's great. It looks OK, but you don't anticipate the performance issues. And also, there are certain parts of your apps that are more critical than others. And I'm sure you've all run into those, and it's similar in store apps. What is important in store apps, we'll go into a little bit about that. And there are a lot of other talks that have already gone through that, and I'll point you to those talks so you can go and watch those if you've not already attended those. So based on what we did over the last year or so, I picked up some of the top issues. There are a lot of issues, but I wanted to pick up the top issues and talk to you guys about that. And over the next few months, we plan on addressing these in more detail through blog or documentation and things like that. So first issue is about boundary. WinRT and your application. You're writing your application in C++. WinRT is, you have to talk to WinRT, so you have to go across a boundary. When you're talking to Win32, you are going across a boundary. WinRT is a different boundary. So let's talk about boundaries. Then there is string theory. So let's talk about strings, because strings show up in a lot of places, and it becomes very important that you deal with them in a performant way. Then there's collections and collections. There's two types of collections. One is the standard collections that you know from the standard library, and then there's the WinRT collections. They are different. There are issues there when you go between one to the other. So let's talk about some of the common issues we have found. Then figuring out CX is an abstraction on top of WinRT. So we give you a high-level abstraction. You don't deal with low-level interfaces. You're dealing with the types in WinRT as objects, not as an object that implements a set of interfaces. And what happens because of you using the abstraction? What are the issues that show up there? Then there is the other issue, which we keep getting this question all the time. Should I use class or should I use a ref class? And let's talk about that a little bit. And then finally, XAML data binding. A lot of the store apps that you guys may be writing are using XAML. You may be writing DirectX apps, but you may be using XAML for some critical parts like menus or things like that. But XAML data binding has some issues. So we'll go over that briefly, because there are more talks that were already in this build conference that talked about XAML and data binding. So I'll point you to those and give you just a high-level overview. So for each one of these, at least for the first 3, that's 2, 3, and 4 in the list, I will sort of highlight the issues, do a small demo to walk through and how we can go address those, and then a quick guideline based on what we discovered during the demo. And then for the last 2, I'm going to talk about the details and go through guidelines, because it's really trying to do a demo for that. It's going to take a lot more time than we have here. So let's go to the boundary, because a lot of these other issues are about boundary. It's about your C++ code, using your C++ types, and then talking to WinRT, which has its own set of types, its type system, and how do you go across the boundary. So knowing your boundary is very important. When you go across the boundary, when you're getting data from the boundary, it's very important. So here's a very simple diagram of what you want your app to be. You want the input, you want it to directly go to your logic, and once you're done with your manipulation of the data, you want to send it directly to the output without a lot of friction in between. So as an analogy, how many of you flew in for this conference, took a plane? How many of you flew from outside the country? Okay, that's good, because I'll use an analogy and then we'll talk about some of the boundary issues. Let's just take you get off the plane, and your goal is to go to the baggage claim, pick up your baggage, and walk out of the airport. So you're entering the airport, getting off the plane, pick up your baggage, and walk out. Okay, for people who just flew domestic, what was the experience? Did you have a lot of issues there? I think yes, there were issues because a lot of us had delayed flights. But once you got to the airport, you walked out, you went to the baggage claim. Hopefully it was there by the time you got there, you picked up your luggage, walked out. Very simple, no friction. And some of us didn't even check in any baggage, so you just took your baggage and walked out. So simple. How about people coming from outside? Okay, I get off the plane. You have to go through immigration. Right. There's the first step of immigration is something that is really not affecting you, but you have to go through immigration. You go through all of the process. You go to baggage claim. Hopefully it's there. You pick up the baggage claim. You don't walk out immediately. You go through customs. And then you walk out. So now, in your process of just entering the airport, getting off the plane, and exiting the airport, you have, from your perspective at least, there are obstructions to you accomplishing the task. So similarly, these are boundaries that you hit. And again, one of the things I want to point out for people who came from outside the country is when you enter the immigration, you see like 2 lines. Oh, you're a US citizen, you go into a line, that line moves really fast. You're not a US citizen, then you have to go through a different set of processes. And so if you consider yourself to be the data going through that immigration channel, okay, I am a US citizen, so okay, you go into that line and you're fast. I'm not a US citizen, you go into a different line, you're asked a different set of questions. So the friction of just going through that one transformation of getting into the airport to get to your baggage is different based on the data that's coming in based on different boundaries. So let's talk about boundaries in our world, which is programming. You're getting data from somewhere. What you really want to do is focus on the app logic. That's where you want to spend most of your time. But unfortunately, there are boundaries. So let's talk about some of those. And this is not very specific to any one OS or one platform or WinRT or anything. You see this all over the place. So first is data transformation. Think about the world where you're now talking to web services. Most of those, the data you get back is UTF-8. Most probably your logic is written to deal with Unicode, WCHAR T star, so you're going to do a data transformation. that's one of the things that you do. You could deal with UTF-8, but normally in C++, there is no support for UTF-8, at least in the standard. And most people are better off dealing with wchar T star. So they choose to do the transformation at that point. Then there is type conversion. You might say, hey, you know what? I am getting a wchar T star from somewhere, but I want to deal with W strings. So you are doing a type conversion. There is no transformation of data. It's the same exact data. If you look at the contents of the buffer, it's the exact same buffer. But you are choosing to make a data conversion here. Not a transformation, it's a conversion. And what happens in a lot of these cases is you end up with a data copy. So here's where the friction comes in a lot of times, is because it's data is coming in some format. Your app logic expects data in a different format. You have to go through this conversion. And on the other side, you have the same thing. You are generating, your app logic is generating data in some format, and your output is different. And this is especially true for people who are writing app logic that could be used across different platforms. So your app logic is agnostic to which platform, and then for each platform, you're going to try to use the right output. So this is the boundary. And trying to reduce any of these blocks helps you spend more time in the middle box, because that's really what you want to be spending most of your time in. So in general, I don't think what I say here is going to be new to a lot of you, but I just wanted to highlight that WinRT is a boundary. It's boundary just like Win32 or boundary on any other platform when you talk to the OS. And these are the normal guidelines you end up having, which is try not to go across the boundary all the time. Try to reduce the number of cross-boundary calls, especially when there is data transformation or data type conversion or copies and things like that. Not always in your control, but if possible, try to reduce those. So think about converting your app logic to use an algorithm that doesn't require transformation or conversion. Use algorithms that help you get the input, deal with the input data as is. So as an example, if we think about web services, you get UTF-8, and don't immediately convert. Is it possible to use an algorithm that can take UTF-8 and then as an output generate W strings? There. Now what you have done is you have, instead of just having a step that does a data transformation, that's essentially just a copy of logically the data is the same. First step of your app logic could deal with the UTF-8, and then the rest of the app logic remains the same. So that's one. Think of ways to reduce those. Again, type conversions. Is there a need, if you have wchar T star, is there a need to immediately convert it to W string? Are there algorithms that can deal with wchar T star and give you W strings as output? So these are normal guidelines that you see when you're talking about boundaries. So be aware of the boundaries. OK, so that's about boundaries. I wanted to cover boundaries because there's a lot of questions about that we keep getting asked about, oh, I'm making this call. And it's like, oh, you're immediately, why are you making 100 calls across the boundary? It's costly. And so be aware of those. That's the first set of guidelines. Be aware where the boundary is, and be aware of what's happening at the boundary. Let's get to strings. Strings, essentially, a lot of output is about strings. There's a lot of data that goes out as strings. There's a lot of input data coming in as strings. Especially with web services, a lot of data is even integers and floats, and everything comes in as a string that you end up converting. So let's talk about strings. So specifically, now I'm going to go, the rest of the slides is about specific to WinRT and the boundary between WinRT and your C++ code. So let's talk about platform string. Platform string is the abstraction we have for the WinRT type in Windows. So Windows has a string type. Low level is hstring, it's just a handle. But the key characteristics are it's immutable and it's ref counted. So if you take additional references to the string, it just increments the ref count. When you let go of the reference, it decreases the ref count, and when the ref count goes to 0, it does the cleanup. It's also immutable. So once you have a string, it's illegal to change the contents. It has advantages in the sense that you can have multiple references to the string and not worry about it changing. But it also has other problems, which is how do you deal with C++? C++ doesn't have a concept of immutable string, at least at this point. As in, when I say C++, I'm talking about the standard. There could be other libraries that have these concepts, but I'm focusing more on the standard library because all of us here know standard libraries. A few of us may know about different set of libraries that not everybody else is aware of. So when I say C++, I'm essentially talking about STL and the standard. So there's duplication. When do we end up with duplication with platform string? Okay, if you want to go from a platform string to a standard W string, it is a copy. It is a type conversion. The contents are exactly the same, but we need to allocate buffer for W string, make a copy. When you look at the buffers, they're exactly the same contents. W string has no way of saying, here's a buffer, go take ownership of it. There could be some very complex ways of doing that, but in theory, W string wants to allocate its own buffer and manage it. How about going the other direction? You have wchar t star, you have W string, you want to go to platform string. Most of the times, you end up having to make a copy, and that's because it's a ref counted string. It has very specific rules. It's immutable, so you have to make a copy. So what is the problem with having duplicate data? So I just want to point out, whenever you see that caution sign there, it's something for you to be aware of. The overhead, there is an overhead there. It's not necessarily bad, but be aware of it so that you know what the performance implication of that is. Duplication, basically allocation, copy. So if you end up having large strings as input, and then you just make a copy of that, you're now essentially doubling the memory usage of your application, which has other performance issues. So be aware of those. Not good to just blindly copy all the time. So let's talk about, let's go to the demo, talk about a few cases as to how we can try to reduce some of these copies. And okay, so before I start, first thing I want to ask you guys is to make sure that everybody can see this, can read the font. Font size is okay. People at the back, you can read what's on the. Okay, great. If you can't see, it doesn't make sense to go through the. Okay, so what I have here is a very simple blank XAML application. I'm not going to type any code because I don't want you guys to see my typing skills. That's not the important part here. I want to make sure I give you the message of what's happening. So what I want to do in the string demo, just I've done all the setup of this. I'm not going to go through this. And these 2 lines are just to help me out. You don't need, so that we focus on what's important. I would not do this exactly this way if it was real code. This is just demo code. So let's focus on the function. So what I want to do here is I have a, let me see, I just wanted to show what's in the XAML page. Unless the designer's not. Anyway, this is preview, so we do have some bugs. So let's go through this code. what I have on the XAML is a, maybe I can try running. Okay, so I have an input text box, and when I click on the button, it's going to do some processing and puts the results of that processing into the list box at the bottom. That's simple. And as you might sort of see from what I have there, it's essentially parsing the input string and finding the words and then putting it into a list box is all I'm trying to do here. So let's go back. Okay, so first line there. Okay, instead of me going through the code, do you guys see where there are copies happening? Anyone? Maybe I should put line numbers. But here's a copy, because we are taking input, that's the text of the input text box, getting a platform string out of it, and immediately creating a W string. And then I am creating a regex. I have the regex here. I create an iterator that lets me iterate through the each of the word. And then, so where's the other copy? This is a copy. What's happening here is regex, when you ask for a W string or a stir, it has to create a W string for you. Or by just using WS regex, you are ending up making a copy of your buffer of each of the word. So there's a copy there, and then there's a copy here. So we end up with 3 copies. Do we need all of those? Right? I mean, there's a copy for the input string, and then there's a copy of each of the word, but each of the word is copied twice. Once to create a W string from the input buffer, and then to create a platform string from the W string. Okay, so I'm just going to run it so that you guys can see what's happening. So just the default text from our XAML app. So it just parsed the words, nothing fancy. I'm not trying to do anything fancy here, put the words in there. And I don't think my regex is sufficient to handle non-text, non-space delimiter. So it's just a simple thing. So it works. So how can we make this better? So let's go down here. You know what? Regex has a version that can take a wchart E-star. So let's use that version. Regex iterator. There's a version that takes a wchart E-star. It takes iterators. Going from platform string to a wchart E-star, you can do that without a copy, because we have a way for you to get the begin and end of the platform string. Because it's immutable, we can give you those. You don't need to do anything. You just call begin and end, just like you did with WString. So now what's happening is that I'm just making I have a local variable here because I just want to make sure that something else is not changing the text in the text box. So we have stable input, but that's just a addref. It's not a copy. So it's just incrementing the ref count. And then here, I'm using begin and end, just like you would use with other types from STL. This works. So we walk through this. And then the next thing I do is, since we have wchart E-star, there is a version of platform string that can take the beginning of your buffer and the length and create a platform string based on that. So there is no need for you to create an intermediate W string and then go to a platform string. So by doing this, what we have done is eliminated unnecessary copies. We have only left with a copy that's absolutely required, because that's required to go to WinRT. There is a way to go to WinRT when you have input strings, input parameters. You're calling a WinRT API. You have input parameters, string types, and you have, let's say, W string. You can pass it to WinRT without a copy. We have a type called string reference. However, what happens with string reference is that there's two requirements, that the input buffer be null terminated. In this case, it's not, because when regex is giving me those ranges, it's not creating a duplicate copy, it's just giving me ranges, not null terminated, so I can't use this. If I change the code and I run it, you'll get an exception. So what we essentially do with string references, we say, you give us a buffer and you say this is a valid string, null terminated string. We will sort of create a facade over the buffer you gave us, and we pass it on to WinRT. On the other side, if they take an additional reference, they get a copy. At that point, they get a copy. If they just inspect the string buffer, the contents of the string, and don't take an additional reference, there is no copy happening there. Of course, it comes with certain restrictions, which is for the duration of that call, make sure that you do not change the contents of the buffer that you said is the string. And don't change its contents, make sure it's valid for the duration of that call. So there are ways to do that. I can't use it here because it's not null terminated. So that's the string. So that's one of, so why am I talking about this? It looks very trivial, but we have seen over and over again where people are, I just want to go from WinRT to my STL type, so I'm going to do a copy, I'm going to do a type conversion, and resulting in a lot of perf issues. So these are, and by doing this, we are not using WinRT types anywhere with STL. STL is just saying, I want an iterator, and we have an iterator on platform string. It works for you. So let's switch back to the slides. So based on this, what are the guidelines? I didn't talk about this one, but a lot of people have said, I'm going to use platform string A equals hello, platform string B equals A plus world, and keep doing that. Remember, platform string is immutable, so we cannot change the contents of that string. Every allocation is a copy. Use one of the C++ string types. WString has better allocation models where it tries to grow the buffer exponentially or whatever algorithm we use today, and so it's more efficient. Do not use platform string as a string builder. Use a C++ type. So use string hat with iterators to interop with STL. I just showed you that in the demo. Use string hat iterators to interop with your application logic. Let's say your application logic, the first step is you only have a function that takes a W string. Think about adding a version that takes iterators. Not platform string. Think about adding an overload that takes iterators. Not only does it help you deal with platform string, but let's assume on some other platform you have a string type that requires a copy to go to WString. Most probably there's a way to get iterators on that string type, and you can use that with your app logic. So very small changes can help you eliminate these unnecessary copies. And if in WinRT, in your application, if you have a string that you get from a WinRT application, and all you're doing is you're not really changing anything much, or you're not even looking at it, and you're just passing to another WinRT API, just hold on to it as platform string. Don't do unnecessary copies. Yes, it may pollute some of your code, but most probably what I've seen is cases where somebody wants to hold on to a file name, and later on they want to pass it to a WinRT API to open the file. There's no need to make a copy. See if you can hold on to platform string as it is. So eliminating copies, and these were the key issues we have seen. There are a lot more, but not as high as, not as often as this. And since we only have 1 hour, I'm trying to focus on the key issues. If you have specific questions, we can definitely talk about that and get to them. Okay, so, and then the last one is use string reference for in parameters, because that helps you eliminate any copy unless the other side decides to hold on to a reference to it. Okay, next topic is collections. And collections is not as easy as strings, because standard collections has its own set of rules, and Winarti collections has its own set of rules. Let's talk about Winarti collections. First point is very important. Any change you make to a Winarti collection most probably results in a notification being fired, or at least going through the logic to see if there's anybody registered to receive notifications. That is the specification. In Winarti, most of the collections require you to implement observable, so that if somebody is holding on to a reference to the collection, they know when the collection has changed. So change triggers notification, insertion, deletion, changing elements, all of them triggers notification, and they can be very costly. Element access. Okay, Winarti is all based on virtual functions, interfaces, which are all virtual functions across the boundary. So whenever you access an element, you're making a virtual call, and the requirement is when you say get at some location, we have to do checks to validate that the index is within the range. There are good reasons for doing that. We have had a lot of security issues due to indexes being off by 1. And when we designed this API, we said, you know what, when you're talking to the system at this point, we want to make sure that it's all valid and we don't open up a set of issues that can be eliminated. However, it also causes performance issues. So it's always a trade-off between security and performance. Sometimes we get to have both, but most times we have to trade off one with the other. These are not an issue if you have like 5 elements or 10 elements in the collection. It doesn't make a noticeable difference. However, if you end up having like 1,000 elements, 5,000 elements, these all add up and may have a significant performance impact. So let's go through a demo, talk about some of the issues and how we can get around them. So here what I want to do is, it's using almost the same code as the previous time. All I'm changing here is like I'm parsing the words and putting them in the reverse order. So you can easily imagine that you're getting some feed from a web service that you want to put it into a list box or some output or some control where you want to say, okay, I want to order the latest feed first and then the rest. At some point, you may also want to go and change it because now some data changed. You want to remove like the last 5 posts and you want to add 5 posts at the beginning. So I'm not going to go to, I'm just using the same parsing example to sort of simulate that. But this is something that's I have seen in real world cases being used with people trying to use feeds to populate controls. So what do I do here? First is, I need to I'm going to create a set of items and put it into a list box. So I need to obviously create a vector. So I'm going and creating a new platform vector, which is a Winarti type. And then I iterate through the words, and I insert the words at the beginning of the collection. So obviously, there are other issues with respect to moving everything. However, behind the scenes, we use standard vector. So whatever optimizations are there to make this faster, all of those kick in, except that we had to do all the notifications and everything every time. OK, so very simple. Go put it there. And OK, so we create a vector. We set the item source for the list control to be that vector. And then I keep adding the elements. What happens is that as soon as I set this line, that's a list box in XAML. And XAML automatically subscribes and says, hey, let me know when something is changed, because I need to go update the UI. I need to show the new element whenever it changes. So it goes and actually subscribes to the notification. So every time I'm adding an element here, XAML is getting a notification. It is doing work to figure out what to change in the UI. Maybe it's doing it in a different thread, but it is kicking off all the code to go update the UI and then you can now see the issues here with performance. Not only are you just, it's out of your control. You have no idea what happens here. So that's initially creating the data. Now let's talk about what happens when you change the data. Okay, so here I want to go and say, I've got a new set of words. I want to go put them in there. Okay, so I want to first remove half of the elements. So I'm going and removing half of the elements. Every remove is a notification that XAML receives and does something in response. And then we go add the new elements at the beginning. Again, you're getting this. So imagine if there are 100 elements. You have 100 items in that collection. You remove 50, add 50. Right? You're sending 100 notifications to XAML, and then each of those XAML has to do something because it knows the collection changed. So what can we do here? Before I go into what we can do here, I just want to show you that it works. I think it's already running. So here I'm just getting your text. So let me just step into one of these. So if you look at insert at, right? This is just a wrapper that we wrote to call into vectors, standard vectors version of the API. You see all of these things happening, which is essentially saying the increment counter is about view. So if somebody has a view of this collection and they want to know when the view is out of date, we need to do this sort of work so that when somebody else who has a view that's out of date, we can let them know it's out of date. Then there's the validate bounce. Then there's validate size, all of these things. And this is the line that actually goes and puts the item into the vector. And then this is the notify inserted. So you can see all the extra work that happens here. Okay, so let's go populate F5. So it's added these words, right? And so now let's just reduce it and then say add these. And it's going through the code we already looked at. And if you look at it, it's added these words at the beginning, and it's left some of the old words in there. So what's happening here is a lot of notifications. You have no idea what's happening on the other side. So how can we reduce this overhead and improve the performance? Okay, let's talk about initial population. You don't need to create a platform vector and add items to it. Standard vector can hold on to WinRT types. Platform vector internally uses a standard vector. So just use a standard vector to initially populate all the items. So this is standard code. I'm creating the string, putting it into standard vector. And then here, this is another interesting point. So I'm creating a new platform vector. And what I'm saying is, since this standard vector is local to that function, at the end of that, as soon as we exit the function, the memory for standard vector is going to be released. Hey, let's move it into platform vector. Let's not do a copy. So what you have gained here is you're quickly populating your collection. And since that collection is no longer useful once you exit the function, just move it into platform vector. So what ends up happening here is that there's no notifications, there's no additional checks. You created your collections really quickly, and then you move all the data into platform vector. You assign it to the WinRT. You pass it to WinRT. There you go. So you saved a lot of work. So that's one step. So now how about changing the collection? And this is where I want to talk about going through and going through the elements. Okay, so here, since we don't have a local copy. Let's just use the collection from the list and get the old items back and remove half of them. So our previous step we learned, let's not use platform vector to create data, since we are modifying significant number of elements here, which is half the elements. Let's create standard vector, add the new items in there, and then go get the collection from the item source, walk through each one of these, and then once we are halfway through, let's exit. One of the key things I want to point out is, I don't know how many of you know this, but with range-based for, it's very tricky when you use auto. Make sure to use auto reference or const auto reference if your collection is not a basic type. You should just say this, there is a copy. Because auto item at that point is a string hat, and when you do the assignment, it's a copy. In string hat, it's a ref count, incrementing the ref count, but if you have your own C++ types, it'll do a copy. So make sure you use the right type with auto in your range-based for. Okay, so we walk the elements. So here what's happening is for each of these, when we walk this element, it's calling over the boundary. It's calling get at on a iVector interface, which is a virtual call. And on the other side, it's doing all the validations to make sure that it is inside the range and it's valid and all of those things. So there you go. You have a lot of work happening there. But however, on the other side, what we want to do here is we don't want to fire many notifications. We can go and just say replace all the elements with this contents of the vector, and that will fire one notification to XAML that says, hey, the collection, every item in the collection is changed. If you're changing a lot of items, then there's one notification. XAML can do all its work in one pass as opposed to every item you change. So saves a lot of work. Okay, great. Now, how do we reduce this code? How do we change this code? One other point I wanted to point is array reference. I talked about string reference earlier, where you could give us a buffer and we would sort of create a WinRT facade. Array reference is the equivalent for array hat. You give us a buffer and you say, okay, here's the buffer of string hats, and it has X number of elements. We go create a facade. There is no copy. We just pass it across the boundary without a copy. Okay, it's great that we have saved a lot of copies here. How about iteration? Okay, so here's how you can change the iteration. All the collections have a way of getting multiple items out of the WinRT collection. And you can go get all of those elements at once instead of going through each item. So all the validation code is run once for the set of items you get. So let's see how we can do that. So here I create a standard vector, go get the new words, inserts into standard vector. I go figure out how many words are there in the previous collection. And since I only want half of them, I calculate the new size of the vector. I resize the standard vector to allocate space for them, for these elements that were in the old collection. Then I'm using array reference to take that buffer that was allocated in standard vector, pass it to WinRT, getMany, and getMany just copies all the elements into that buffer. And then we get all the data back, and then we go and call replace all. So this has eliminated iterating over possibly, let's say your collection had 100 items. You don't need to iterate over 50 items individually. One call, you get back all the data. So just to go over this one, let's see. Okay, so let's populate. So I'm just using new So we have populated everything. I'll just go to step 2 and walk through it. Okay, so here I have the, let me put a breakpoint here. Okay, so if we look at vector, you see there are like exact number of items that were added. When I resize, you will see that there is now empty elements put in there. I use that same buffer called getMany. It's got the items from the previous collection. And now we go replace all the items. And it has all these items here. So there are ways of getting around these cross-boundary copies by modifying the code slightly. And collections is interesting because if you have a, let's say, very small number of items, I don't know if this makes any noticeable impact. But you can easily imagine apps that show news feeds, which have like 200 items, and they're changing often. It may make a noticeable difference when those items are changed, where user doesn't notice some responsiveness where the UI is hung for a little while. So let's go to the slides. Okay, so guidelines: use standard vector for initial population, use replace all, use getMany. Eliminates a lot of the issues you saw in the things to look out for with collections. The next one is, who are you calling? Everything is based on interfaces. What happens? So CAS, basically it's about CAS. In Winarty with CX, you're dealing with an object which is composed essentially, it's based on a set of interfaces the object implements. You never get to look at the object. If you're going to program without CX in C++, you would have to deal with each individual interface. So with CX, you get the abstraction of dealing with the object, but it does come at cost because underneath, we have to go do that work for you. So when you invoke a member on a non-default interface, we have to do a cast. If you are invoking, so let's say you have an interface hat, and you're invoking a member that's on an interface that's required by that interface, then there's a cast involved. And when you have function arguments and you pass the object, but the function takes an interface that the object implements, we have to do a cast. So there are those situations where a cast happens. However, if you have, let's say, some object 1, which is a type, and you have object 1 hat, and its default interface is I1, then you're calling a method on I1. There is no cast because object 1 hat is essentially a alias for I1 hat. So there is no cast there. And why are casts costly? Because it's essentially a query interface. Every time we need to do a cast, it is a query interface. For all Winarty types, when you do a cast, it's a query interface. And query interface has basically 2 big issues. One is it's a virtual call, so you have to go to the object and say, hey, give me the pointer that is corresponds to the interface that you're looking for. And when you get that, we also need to increment the reference count on the object, which is an interlocked operation. You know, a lot of times interlocked operation may not feel like a big issue, but on certain platforms, interlocked operations are costly. They cause a lot of issues at the low level with caches and things like that. So depending on your situation, it might become very critical in terms of performance. So let me go quickly through the demo. So I'll just walk through this demo. So let's talk about this. Let me see if I can. OK. So here's my type. I have interface I1 and I2, and I have a class that implements both of these interfaces, and I1 is the default interface. So that's our types here. And here I'm making a call here. call. And demo component is essentially of this type. So if I go there, it's just a member function that I initialize in the constructor of main page. So this call, no cost, because M1 is on the default interface. There is no cost happening there. These two are costs. What happens here is that because M2 is on interface I2, both of those two calls are on interface I2, we have to make a cast to I2 and then make a virtual call to that function. So essentially what's happening behind the scenes is query interface for I2, make a call, let go of the pointer, query interface for I2, make the call, let go of the call, let go of the interface pointer. So, okay, looks trivial, may not make a big difference. However, think about this being in a loop where you're passing data to it, different data based on different items or whatever you have. That can become costly because if you iterate the loop 100 times, then you're doing like 200 query interfaces and 200 add refs, 200 releases. So it can become costly. Optimizer can help here sometimes, not always. And how would I basically resolve this? Just make a local copy, cast it to the right interface locally, use the local, do the query interface explicitly once, and then use it. And so if you have a loop like this, you can then just say for, right, whatever. Oh, okay, sorry, I'm not yet used to the formatting, so that's a way to help you here. And unfortunately, we do not have a way of letting you easily find out what is the default interface, but hopefully we can give you some solution in the future that helps you track these down. Going back to the slides, Optimizer will optimize it sometimes, but it cannot optimize any variable that's escaped. In Optimizer, on people who work in Optimizer, they talk about escaped variables. Escaped variable really means if you have a global variable, or you have a member variable, or you take the address of a local variable, then the Optimizer really cannot track all accesses to that variable, and it cannot determine whether it's safe to optimize or not, and it says, okay, I cannot optimize. If you use some of the techniques like LTCG, it may be able to do more work, but there are limits to what the optimizer can do. So if the optimizer cannot help you, there are ways you can get better performance, essentially by using local variables. So class for app logic. So here I don't have demos. I'm going to walk through some of the issues. We always get questions about, should I use ref class or should I use class? What's your view? Class or ref class? So let's talk about what it means. C++ classes gives you the flexibility. You can have an instance of that on the stack. You can have unique ownership. You can have shared ownership. For your app logic, it almost always makes sense to use C++ classes. So let's talk about a ref class hat. So when you have a R hat, what it really means is you're holding on to what is equivalent to a shared pointer of n, which is n is a C++ class type. So in your app logic, you don't always end up using shared pointer. Just like that, you don't want to use R hat everywhere. You use shared pointer in certain places. R ref class you use in cases where you want to talk to the Winarty. So don't go start using ref classes. Oh, it automatically gives me shared pointer characteristics, so let me use it. It has overhead. Be aware of that. So the next question is, oh, if R hat gives me shared pointer characteristics, and it's why should I use shared pointer or should I use ref class? I would still say use shared pointer, because once you have R hat, a lot of times you have the overhead of WinRT, which you may not need for some of the types. If they're not talking over the WinRT boundary, you don't need that overhead. So default to C++ class for your app logic, use ref class only when required in places where you're talking to WinRT. So this is more general in the sense, use stack allocation or unique pointer for most of your types in app logic, because that gives you the best performance. Use shared pointer when you have really require shared ownership. I've also seen the other case where people are saying, oh, shared pointer is great, I'm going to just use it everywhere, and they end up with performance issues, because what was really correct for that particular case was unique pointer, but they ended up using shared pointer. So be very aware of those, and then use ref classes when you are interacting with the boundary. Don't use ref classes for all over your code. Even if you like it, there is overhead from a performance point of view. So be aware of those. XAML data binding. I'm not going to go into a lot of detail here. I'm going to just talk about some of the guidelines, and I'll point you to talks that go into a lot more detail about what happens in data binding. So in data binding, with the VS 2012 templates, we created sample data for when you created a grid app, store app. We created sample data that had iNotify property change. iProperty notify change is only required if your data changes after it's populated. Not the set of items, but the contents of the item changes. Then only then implement this interface. Otherwise, you don't need to. How about property getters and setters? If your UI only reads data from your data type, but you have no UI to go modify this data from the UI, there's no need to have a setter, because at least a public setter, because that's only called by XAML when you change something change the data in the UI. So if you only have data that's read and displayed, there's no need to have a setter. You only need a getter. And keep the data model hierarchy shallow. Why is that? Because you're using WinRT types here, and WinRT inheritance is not the same as C++ inheritance. So try to keep that shallow. Don't make your data model hierarchy very deep, because you're using WinRT inheritance, you're not using C++ inheritance. It comes with an overhead. And then the key point here is that minimize what you do when XAML asks you for information. Don't do a lot of calculations, because when XAML is asking data for data binding, because of data binding, you might have 100 elements, XAML may have to call back to you 100 times because you have 100 elements on the screen that have some type of data binding, and if you spend a lot of time there, then responsiveness suffers. I just want to give a summary here, but here are some great talks that talk about XAML and gives you an idea of what happens in XAML when it's data bound and things like that. And there are techniques to not use data binding if it's suitable for you, but there are very easy ways of using data binding but still get good performance and responsiveness. So we talked about all of these things. There are a lot more patterns. Believe me, I've seen that code, except we don't have time. I think we are already out of time. So to just close, WinRT is just another boundary. Yes, it's new, it's different, but you are dealing with boundaries. Win32 or some other boundary, this is just another boundary with its set of issues. Again, don't go optimize without measuring. Yes, these guidelines help you be in the right path so that you don't have a lot of issues, but also, as I said in the collection, it may not be worth replacing all the elements if you're only going to change one element out of 100 and you change it once in 5 minutes. It's not worth the overhead there. Measure and then make the change. And then use the guidelines that are there. We'll have these slides. We'll also have more blog entries on the VC blog site coming out over the next few months, talking about each of these in more detail. And the guidelines really help you with productivity, with correctness, with performance, so that you don't end up with suffering performance issues or any of these other things through a set of very minor performance issues, which by themselves may not be very critical, but you have them all across the code, which makes your app not responsive. So last point, so we do have a way where you can give us feedback about VS. There were sessions here where there were people you could sign up, but since it's already 1 o'clock on Friday, you may not have time to go there, and they're closing up soon. However, that email is still valid. You can send email to them, and they can set up some session with you to give feedback. And this is essentially the user experience team in Visual Studio. Okay, so that's the end of my slides. If you have questions, we can talk about them. I think we are out of time, so maybe 1 or 2 questions, and then we can. I'll be here. Okay, so thanks.